I would like to introduce the speaker of the day, Mr. Baskar. Mr. Baskar is a mechanical engineer by qualification, chemical engineer by experience, and software engineer by passion. He has 37 years of petroleum refinery experience in various arenas such as petroleum refining, production planning, process scheduling, process engineering, and oil movement and storage. He had retired as Deputy General Manager from Chennai Petroleum Corporation Limited. He is an advanced Excel trainer and trained more than 120 Excel users in basic and advanced Excel. He is a quiz master and conducted various types of quiz on refinery operations, energy, vigilance, etc. He is a virtual tutor and coaches science for government school students. He is a member of Institution of Engineers India and Indian Institute of Plant Engineers, and held the position as Secretary in Tamil Nadu chapter and also as National Treasurer. I request Mr. Baskar to resume his guest lecture. Thank you, sir. Please go ahead, sir. Over to Mr. Baskar.
Yeah, thank you, Mr. Prakash, for the warm welcome. And let me share the screen to start our lecture, right? Yeah, good evening, all of you. Today, our topic is going to be quite complicated. Can you find the topic of the day from the crossword? It is petroleum refinery process. It's quite complicated as the crossword. Let us crack it slowly from the basics, right? Now, what is hydrocarbon? Hydrocarbon, actually, organic chemistry is the study of structure, properties, and composition pertaining to compounds containing carbon, right? If the compounds are compounded with hydrogen, then it is called hydrocarbon compounds. Okay, now let me give one example of hydrocarbon compound. Here you can see a compound with 1 carbon and 4 hydrogen. Okay, now 4 molecules of hydrogen. Can someone give the answer? What is this in the chat box? What this hydrocarbon is called as? You can use the chat box for answering, or yeah.
No, now it is disabled, sir. Others cannot chat. It has been disabled.
Yeah, okay, no issue. Okay, this is called as CH4. Yeah. CH4, it is called methane. Okay. We will have the chat at the end as per Mr. Prakash's guidance. We will have the chat. Let us complete the lecture process, then we can ask questions, right? So, how the crude oil is formed? Hydrocarbons are formed through slow decomposition of organisms and organic substances in crude oil in the underground cavities of Earth. It's a complex mixture of made of different hydrocarbons. And based on the value and demand, it is also called as black gold, right? Because you can see that the entire world economy is roaming around this on the crude price, the entire global economy. And these components in the crude are separated into many fuels in a refinery, where we are going to discuss in detail. So let us understand the formation of crude oil in detail. The tiny sea particles and animals were buried. Let us see the crude oil formation. Tiny sea plants and animals were buried on the ocean floor. Over the time, they were covered by layers and silt and sand. Over the million of years, the remains are buried deeper and deeper. The enormous heat and pressure turn them into the black gold. So once the black gold is found, then what they do, we drill down through the layers of sand, silt, and rock to reach the formations that contains gas and oil deposit. We recover oil and gas from the bottom of the sea. So this is called oil exploration. And basically, we are talking about hydrocarbon family. All the hydrocarbon family can be grouped into 5 groups: paraffins, isoparaffins, olefins, naphthalene, and aromatics. So these 5 have different characteristics and different properties. That is very detailed. Let's not go into the detail. And basically, on the outlook, paraffin hydrocarbons are good for lubes, and aromatics hydrocarbons are good for fuels. These are broad guidelines for hydrocarbon family. Now, we'll go to industries. From the science, we are going to industries, right? Industries handling hydrocarbon. First one is upstream industries. What is upstream industries? It explores the crude oil. Basically, it finds out where the crude oil is available across the world. And then once the exploration is successful, then it goes for developing the explored field to recover oil, to receive oil. And then the production of crude oil, and to some extent, some treating also is taking place. So these are all the industries handling hydrocarbon. You can see the picture. Depending upon the depth of the oil available, we are using different types of oil exploration methods. First one is fixed platform, then compliant tower, sea tower, floating production system, tension leg, subsea system, and spar platform. The usage of the system depends upon the depth of the oil available during the study. Now we come to midstream. What is midstream? It is marketing of crude and petroleum products. Then movement of crude and product through tanker, pipelines, trucks, and rail. And then gas distribution. See, if you see that marketing of crude oil, because crude oil is available only at certain locations of the world, but the crude oil refinery is available throughout the world. So that means the crude oil has to be marketed properly, like any other commodity. Then it has to be brought to the refinery site for processing. And the same way, the products are produced at one refinery at one end, and it has to be distributed to user. So the midstream industry is taking care of all these activities. You can see here that first one is crude tanker, very huge crude tanker of around 150,000 metric tons capacity. You can see that 150,000 metric ton capacity, where crude oil is being transported from the source to the refinery. On the second picture, you can see that a huge pipeline, cross-country pipeline, where the products is moved from one end to another end. It may be one country to another country, or one city to another city. So this is called midstream industries. Now we come to our downstream industries, where refineries are categorized. Refining of crude oil to produce petroleum products, then processing of natural gas, then marketing and distribution of petroleum products. See what happens, once the crude oil is processed and products are produced, then it has to be transported to the end user. If we say we have a refinery at Chennai, and the product has to go to Trichy or Madurai, even at Nagapattinam, right? So it has to be transported in a proper way so that all will get the product. So this comes under the purview of downstream industries. You can see the huge refinery complex. It's almost only just 10% of the entire complex, where you have a lot of pipes, towers and reactors, furnace, etc., etc. And in the refinery, we produce the following products. First one is LPG, which is used for cooking, automobile, petrochemical feed, and then naphtha for fertilizer and petrochemical feed again. Gasoline is also called as petrol or MS, that is used for vehicles. Kerosene is used for household heating. Basically now the demand for kerosene for household heating is totally nil, because almost entire India has converted its fuel to LPG over a period of time. Okay, and then we have aviation turbine fuel that is used for aeroplane fuel, and JP5 that is used for jet engines. You will be surprised to see that aviation turbine fuel and JP5 are the improved versions of kerosene. And many people used to think that aeroplane uses petrol as a fuel. It is not so. It is using an improved version of kerosene as a fuel. And then we come to diesel, that is used for vehicles and some of the agriculture engines. And then furnace oil, which is used for fuels for ships and industrial heating. Then comes to lube oil, where the lubrication of oil, the engine oil, lubrication of vehicles and various industrial machines. We have different types of lube oil catering to different requirements. And then wax for producing candle. Actually, wax is mostly a byproduct of refinery, and it has been very useful for industries catering to candles and other material. And then we have asphalt, which is used for road laying, industrial roofing, and asphalt is also called as bitumen or tar in conventional basis. So these are the products, various products we produce in refinery. And you can see that entire product range is very, very useful for all the public. Now, let us understand the world oil refining capacity. So, throughout the world, we have 94,470,000 barrels per day refining capacity. Okay. And in India, we have 4,300,000 barrels per day refining capacity, which is equal to 4.6% of the world capacity. This is just to indicate how the industrial scenario is there. And within India, we have multiple refineries across India, and both private and government public sector refineries are available. And you can see that Reliance Industries are topping with 33 and 27. And 27, that second one, 27 Jamnagar SES, that refinery is totally exporting the product to other countries. So this is a typical breakup, and you can see that the refineries are spread across India, like Gujarat, Andhra Pradesh, Odisha, Maharashtra, Tamil Nadu, Kerala, Punjab, West Bengal, so that the logistics is taken care, because once you produce product from the refinery, it has to reach the entire people of India. So it has to be logistic. Refineries has been logistic based to cover the entire India. So once crude oil is bought for the refinery, it has to be transported to refinery, right? We have a huge tanker, as already indicated. You can see the large platform in the ship, and underneath we have multiple compartments carrying the crude, and those compartments are interlinked via pipelines, and we have huge pump for loading and unloading of crude oil from a exploration field or to the refinery. So we have different types of vessel from MR, that is mid-range vessel catering from 25,000 metric ton to ULCC cutting to 5.2 lakhs metric tons, TMT. And needless to say that the higher the capacity of when crude we bought, the less will be the transportation cost. So now crude oil has been received into refinery, into our unit. Now our focus is on how the crude oil is converted into products. So basically, as he told that refinery is a both physical and chemical process. We need certain parameters to be maintained for this operation. The pressure, we have operating pressure, vacuum and vapor pressure of gases. And for volume, we have liquid flow and gas flow. And for temperature, operating temperature, distillation point, boiling point. And other parameters are density, specific gravity, both the same, viscosity and pour point, etc. So these are the parameters in a refinery, parameters used in refinery for making different products out of crude. And this is a control DCS system where the entire operation is taking place via instrumentations. So let us focus on now. I'm going to give you a distillation unit flow diagram. Okay, now you have a bowl of mixer, right? Is it easy to remove the groundnuts from the bowl of mixer, right? It's a very physical process. You can just pick it out, the groundnuts, and eat it, right? The crude oil distillation is also similar to that. It's a physical process where no chemical reactions are involved. Right? Now we'll go to the distillation tower. Okay, now slowly watch my cursor. The crude oil, after treating, because crude oil will have some salt. So the salt will be removed through a desalter. We have a desalter in between. After the desalter, where the product crude is free from salt, it will be fed to crude oil preheater. We have a preheater here. Then it enters the distillation tower. This is a distillation tower, huge tower. You can see that. And it is entering at a temperature. Okay. The lighter ends will be in vapor form. It will try to escape through the chimney trays to the top. Okay. Now we'll concentrate on bottom one. The heavier ends will come to the bottom. And here we are maintaining different temperature profile. How do you maintain this different temperature profile in a single tower? That we'll see later now. Once the bottom is reaching 600 degree, then it is taken out as fuel oil. Right? This is a boiling point of fuel oil, basically. So that is taken as fuel oil where you are using for ship and other things. And the bottom is called residue, which is treated in a separate section. Okay. Now you can see that vapors are coming to the top. Right? Once it is reaching the distillation range for C20 to C50 range, then that dry is called lubricating oil, which is further treated in down industries, down units, sorry. Then the vapor, uncondensed vapor, goes up like this. Then at 270 degree, that vapors got into a draw called diesel, right? Then the balanced uncondensed vapor goes up like this. Then it goes to a cut called 170 cut. That is kerosene cut, where the kerosene is withdrawn from this tower. You can see that trays are available on the collection point. This is a collection point where the gases at 170 degree get condensed into this one. Knocked off. The liquid is knocked off. The liquid is knocked off at 170 degree, and then we are drawing as kerosene. Then again this vapor goes to top, and at that 120 degree, the gasoline compound knocked off here, and this is a collection tray where this collection is taking place as gasoline cut. Furthermore, the vapor goes up to the top where C5 to C9 naphtha range is there, and the temperature is maintained at 70 degree, and that cut is called naphtha cut. the uncondensed vapor, right, still goes to top and goes as C1 to C4 gases at 20 degree. Okay. Now, you can see that fractions decreasing in density and boiling point. As you go up in the tower, there will be density will be less and boiling point also will be less. As you go down from the tower, from top to bottom, the density and boiling point will be higher. So this is a logic. And now coming to our main question, in a single tower, how do we maintain different temperature profile? You can see that bottom is, the feed inlet is around 450 degree. Okay, the feed inlet is 450 degree and bottom is maintained as 600 degree. And one portion is maintained 270, 170, 120, 70 and 20. Imagine, can you do that in a flask, your normal flask, your water flask, you can maintain only one temperature, right? But in this atmospheric distillation tower, we are maintaining different temperature at in a single tower. How do we maintain? We are using a system called reflux and pump-arounds. We are not using any temperature rods or temperature elements for maintaining different temperatures. We are using the same fluid. Same liquid as either reflux and pump around. And sometimes we are using different steam also as pump around for heating this, for maintaining these temperatures. So I think mostly I'll recap quickly. This is because this is a very critical unit for the entire refinery. The crude oil is fed into atmospheric distillation tower, where the pressure is maintained as 2.5 kg. So this is called atmospheric distillation tower. 470 degree interest and different temperature profiles are maintained to draw products at different temperatures based on this boiling point of each cut on. Okay, now then these products are withdrawn, right? These are the products I am talking about. Okay, now hope you understand. If you have any question, we can clarify in the later on question. So now we'll move on to next slide. Now I told you not bottom earlier slide, we have a bottom residue where heavy rains are taking place. So that cannot be directly sold as product because that is called vacuum residue. That is residue which is fed for vacuum unit. Similar to crude distillation unit, atmospheric distillation unit, we have a vacuum distillation unit. Okay, now why do we require two distillation unit? I'll answer, right? See, crude oil, the boiling point of LPG, naphtha and other things, this 172 degree, 170, 270 degree, that is at atmospheric pressure. Okay. If we want to distillate the heavy runs at atmospheric pressure, you need to keep higher temperatures. You understand the point, no? See, for LPG, you are keeping 20 degree. For fuel oil, you are keeping 600. If you want to recover lube or other products from the bottom, you need to keep 1000 degree, 800 degree like that, okay, at the atmospheric pressure. So if you start doing that, we can do that. We can do that by maintaining different temperatures. But what happens? The cracking of product will take place. Cracking and coking of product will take place, which is not correct. Coking means it's a carbon deposit will form. So we need to, what we have to do? We have to reduce the temperature. If you reduce the temperature, coking will not take place. But what happens? Distillation also will not take place, right? So we have a solution. Instead of keeping at atmospheric pressure, we are keeping vacuum distillation unit where vacuums are maintained. Okay, that means when the vacuum is maintained, the boiling point of the heavier ends is coming down, which is operable and safe for the operation. So this atmospheric distillation residue comes from the atmospheric tower, goes to the heater for heating, and goes to the primary vacuum tower where vacuum is pulled, vacuum is maintained through ejectors system, around 600 AG of vacuum is maintained. And then we are same way our distillation column, we are maintaining different temperature profile here with lesser temperature for spindle, light neutral and medium neutral. And this tower bottom is going to another heater, secondary fired heater or furnace, we call furnace. And then it goes to secondary vacuum distillation tower where two more products are taken out. Here also we are maintaining the vacuum because to reduce the boiling point. Hope I am clear with this concept. In crude atmospheric distillation unit, we are maintaining the atmospheric pressure and normal temperatures. And in vacuum distillation unit, we are maintaining vacuum at 600 mm of AG to maintain to lower the boiling point of air ends, so that our purpose of distillation is taking place. So now that we have distillated all the product from the crude oil, okay, from LPG to your vacuum residue, this is basically fuel oil. The entire product is being distillated out, right? Now, why do we need secondary unit? What we talked about is primary unit, that crude oil, atmospheric crude distillation unit and vacuum distillation unit are primary unit. Then why do we need secondary unit? When the products are produced in atmospheric or vacuum distillation towers, which is called primary unit, still we need secondary units. Why? Because some of the products are not meeting the specifications like sulfur, octane number, etc., which we'll be dealing in a few minutes now. And some are low value products where productions are not valuable, like naphtha. The production of naphtha in Indian scenario and the demand, there is a huge gap. That means the production is more than the demand. So those are all not viable to produce and sell. So that is one more concern. And some products do not have market at all, like VR, vacuum residue, I talk, it doesn't have any value. So it has to be converted into useful product, useful and marketable product. So we need to have secondary units. So as we go on, you can see that complexity of refinery goes up, right? Instead of, we saw the simple mixer bowl where picking of groundnuts is very easy. Now we have come to a critical stage, complicated stage, which is going to be further complicated, right? Now, secondary unit, that means delayed coker unit. One of the critical delayed coker unit, I will quickly go through, I will not go waste, take more time here. The heavy fuel crude oil, sorry, the heavy residue oil is pumped into the main fractionator and some products are taken out, like light gas oil, heavy gas oil. Light gas oil is mixed with MS, petrol, and heavy diesel gas oil is mixed with diesel. And we have a heavy material that is called coke. That coke is fed through a furnace. It goes to two towers. There are two towers in operation. One will be in coking mode, one will be in operation mode. That means once the feed is into one tower, in this tower, coke cutting water with 140 bar is pressurized through this coke drum, and which is cracking the coke into slurry like material. When this operation is taking place, this coke drum is ready for coke cutting. Already after coke cutting, it is ready for coke removal. The heavy ends coke, that is wet coke, because we are using water, no? That wet coke is received here and water is drained out to the drain pump, and the dry coke is moved to cold coke storage for further movement. It's a cyclic operation, switching over one by one. When this is coke cutting is taking place, this will be on desoy mode, so that it's a continuous operation. Otherwise, no, it has to be batch mode. To avoid the batch mode operation and make it continuous, we are having two drums, which is automatically changing over from fixed time, say 12 hours. 12 hours, this will be on coking mode, and 12 hours, this will be on removal mode. Okay. This is the coker unit. The objective of delayed coker unit is to convert heavy fuel oil into high quality lighter products like LPG. You can see the top one is gas, that is used as a blending component for LPG, then naphtha, diesel component, and coke. In fact, coke is also a very valuable product, but of course, demand is comparatively less than the production. Coke is used in battery industries and other cement industries. Now, let's go on to one more secondary unit called Hydrocracker Unit. Here, this is a gas oil feed, which is fed to a reactor along with hydrogen, right? And the reaction is taking place of, that is, heavy molecules are converted into lighter molecules. And we have a separator because this is already mixed with hydrogen. Gas has to be removed. We have a separator to remove gas, that is hydrogen. That recycled gas goes back as a feed for recycling. And then the liquid portion is going to a fractionator. Fractionator, again, it's a fractionator almost like a distillation column where we are maintaining different temperature profile. And we have a jet fuel, diesel, kerosene, and other products. Okay. And the bottom one, which is unconverted, it goes back to feed for recycling. So the objective of hydrocracking is to convert heavy oil feedstock into high quality. High quality means purity is more, because once we use hydrogen, the purity is more in all products. That is a general thumb rule. High quality, lighter fuel products such as gasoline, naphtha, and jet kerosene. And sometimes we are nowadays we are using this system for lube production also. So this is about hydrocracker unit. And then we have a fluidized catalytic cracker unit. Here, what happened? You can see the graph. Feed is taken inside. You can see the VGO or residue feed. And from the bottom, catalyst also is fed. Catalyst in a fluidized form, that is in a powder form. Catalyst normally in solid form. Here it will be in a powder form or fluid form. It is pumped along with the feed to the riser, where it goes to a reactor. In the reactor, reaction is taking place. On the top, you can take the products, gasoline and LPG and all. And the spent catalyst, you can see the small chimney like. The spent catalyst is recovered, goes back to the regenerator, where regeneration of catalyst is taking place. And after regeneration, some loss will be there. So that will be topped up with fresh catalyst. It is going back to recycle. So it's a continuous process. This operation is taking place continuously. And you can see the temperature profile. The reactor is operating as 490 degree temperature, and regenerator is operating as 650 degree. And there will be a flue gas also, which is also flare to atmosphere after burning. So this FCCU, or which is called as fluidized catalyst cracking, is one of the most important conversion process in refinery product. It is widely used for high boiling, high molecular weight hydrocarbon fractions of petroleum oil to more valuable gasoline and other LPG products. Now, that means the heavier ends are taking place. Sorry. Now we have covered this converting of heavy ends into lighter products. Now we will go to the quality side. That is octane, petrol. So what is octane? The octane rating is a measure of fuel's ability to avoid knocking off engine. You can see the engine, petrol engines are basically 2-stroke or 4-stroke engine, where the movement of engine is taking place, right? So that movement will give you a knocking sound, right? That knocking is measured as research octane number, RON. We call it RON. The higher the RON, less will be the knocking and better for engine, but not better for bus, because higher octane petrols are always costlier. You can see that. And presently we have 3 grades of petrol with RON 91 regular, which is normally used in our bikes and other thing. And there are special vehicles with designed for 95 and 98 octane. And in some of the foreign countries, we have vehicles with which is requiring 100 octane. You can see the rate prices. So, as I already told you, we are producing naphtha also, which is not is not a demandable product, because already fertilizers which was using naphtha as a feed, now they are converted into gas. Okay, so we have a large enough quantity of naphtha that has to be exported. Okay, that export always there will be a loss of export because of pricing issues, and so we have to consume the naphtha in a better way. But the naphtha has got ROIN of 60 to 70 only, where it has to be converted into higher octane like 85 or 80, no, sorry, 91 or something like that. So refineries have plants like continuous catalytic reforming unit and isomerisation unit. So these units are mainly catering to convert naphtha into petrol. So I will quickly go through this slide. We have a system, feed is taking place, and we have 3 reactors, one by one, with different temperatures and maintained. And you can see the gas separator, where again, similar to that, hydrogen also is involved here. And this hydrogen will be taken out as a recycled gas, and some portion hydrogen is taken out from the hydrogen network, because this is a hydrogen production unit. So some portion of hydrogen is taken out as a hydrogen product system. And the bottom is going to a stabilizer. And the stabilizer bottom is called reformate. You can see that reformate in the end. You can see from at the end, and where reformate octane is 100. The feed octane is the feed octane is 80, 70 to 60, and the reformate octane is 100. Okay, now catalytic reforming unit is a unit installed to convert naphtha into high octane called reformate. Reformate is a blending product for making high octane gasoline. Okay, and I told you that one more isomerization unit is there, where the lighter naphtha is going to a reactor along with hydrogen. So that bottom is going to a separator, where hydrogen is getting recycled for further processing. Okay, because the hydrogen is only used as a reacting medium, so that can be easily separated by a separator, and the gas is removed as a recycled hydrogen gas, and bottom is going to stabilizer column, where the bottom is taken out as a isomerate. Here I want to specify one thing. See, the refinery is a very complex refinery, where somewhere heat is required. You need heat for reaction, right? And somewhere you have exothermic reaction. You have exothermic reactions where you have heat is produced out of reactions. So there will be continuous exchange of heat exchange will be there in the entire refinery, where the heat is properly utilized so that the heat balance is kept optimized. Here you can see that the feed is preheated here and goes to the tower for reaction. Okay. The bottom is giving the heat. The stabilizer bottom is giving the heat to the feed. You can see here, no? You can see here, the stabilizer bottom is giving the heat to the feed and goes to the goes as a product. Okay, so that's how the heat balance is taking place, because it's an entire refinery is full of heat exchangers and towers where the heat exchange is taking place in a proper way. Isomerization unit converts linear molecules of naphtha into high octane branched molecule for blending into gasoline or to alkaline units. Thus, the low value naphtha is converted into high value RON with 87. Okay, you can see the difference that catalytic conversion CCR in the previous unit that was producing reformate with 100 octane, and this unit produces isomerate with 87 octane. And coming to the bottom portion of, now that we have taken care of light ends, we'll go to the bottom portion. Lube oil is lube oil and wax, right? You can see the feed is taken, sorry, feed is taken here and it is getting chilled. Feed is chilled so that wax crystals, the lube oil, any lube oil will have some wax. So that lube oil is chilled to a temperature -degrees using ammonia compressors, and we have a solvent like drum. This drum is mainly for that. Okay, and lube oil is filtered out. Lube oil is taken out here and heated here, and then goes to a dewaxed oil. That means dewaxed oil means wax is removed. That is called dewaxed oil. And this dewaxed oil is that is basically a lube product, and that is further treated in other units for making different types of lube-based stocks. And the wax that is scrubbed through in this drum, the wax coating, that is scrubbed through a rotator, and that is getting collected here. And we have a heater to heat the wax, and we have a slag wax evaporator. The bottom is called slag wax. See what happened here, we are using solvent in different operations. So the solvent that should not go along with the product. Okay, we need to recover the solvent and get it recycled. So we have a solvent evaporator, a dewaxed oil, where the solvent is removed or recovered at the top, and same way slag also we have an evaporator where the solvent is removed at the top and getting recycled, so that the products are free from solvent, right? Here also the same temperature profile. Whenever the distillation is taking place, this is also same temperature profile maintained based on the boiling point of solvent. It is getting removed from the top. The lube oil production in a refinery will be very waxy in nature. This wax has to get extracted to enable lube oil meets the product specification. And the removed wax is also a byproduct, which is used for producing candle and industrial wax. That wax coating papers and all, that also is for slag wax. Now, very critical situation. Now we are going to product control. Sulphur. Over a period of time, the petrol, let us concentrate on petrol and MS, petrol and diesel. Petrol from BIS3 to BIS5, it has come from 150 ppm level to 10 ppm level, and diesel from 350 to 10 ppm level. That means the product quality is so stringent. 10 ppm is almost nil. 10 ppm is parts per million. Okay. Almost nil, 10 ppm, because of environmental constraint, because of global warming and environmental conditions, the government has instructed to produce less sulfur material, because the continuous burning is there in the Indian roads, right, or world roads. So the product from refineries has to be treated for sulfur reduction before marketing to public for meeting environmental norms. See what happens, I told you the isomerisation unit and Refinery unit, those units will meet the entire product specification of octane and other product except for sulfur. So for sulfur, again the product has to be treated. So refineries use hydrogen as medium for removing sulfur material. So how the desulphurizing unit is take action, let us understand by a very simple graphics. So here our villain is sulfur, right? So the sulfur has to be removed. And what happens during the operations of refinery? The villain sulfur captures lady, that is hydrocarbon, be it petrol or diesel. It catches hydrocarbon. Now what to do? We have to call only the hero. Who is the hero? Hydrogen. The hydrogen hero comes in and he fights with sulfur to release hydrocarbon free. Okay, this is a simple graphical formula how the sulphur is taking place from hydrocarbon, right? And maybe some of you know the characters, this villain and hero. Okay, now we'll go to the process side. Process side, hydrocarbon is fed here along with makeup. What I told you, that hero hydrogen is taking fed into the reactor, and we are using quench here for maintaining the temperature profiles, and because excess heating will be there. Excess heating will be there, and we control the temperature. We are using quench, and the reaction product is taken to the separator, where the gas is taken out as sour gas and the hydrocarbon is taken out. Hydrotreated means with less sulfur, whatever the market demand. So we can adjust the reaction temperature based on our sulfur requirement, product sulfur requirement. So that is a convenient we have. And the top one is sour gas. During this reaction, this hydrogen will have H2S, right? Because sulfur is removed from the product. It has to come as hydrogen, H2S only. So that is called sour gas. Sour gas is taken here, and we have an amine treating system where H2S is removed from the hydrogen, and the sweet recycled gas, that is called sweet recycled gas, is again recycled as feed, along with the feed. And this rich amine, lean amine is fed to the amine absorber contactor, where it is getting removed through H2S removed, and rich amine is taking place. Rich amine is taking the H2S along with it, where it is further processed to produce sulfur. That is a separate product. So this is a simple method of removing sulfur in any other product, be it kerosene or petrol or diesel. Okay. It is also called as hydrotreating because it is hydrogen is used as a treating plant. So we need to have a hydrogen unit for producing hydrogen, right? So we need a hydrogen. A lot of hydrogen is required. We have a steam reforming plant where naphtha, because already I told you, that naphtha is surplus here. Naphtha is used as a feed along with steam. It is going to a steam reforming process where shift conversion is taking place. That molecules are removed, and we have a then liquid condensate is there that is being removed, and the gas, hydrogen gas, some with CO2 removal is taking place, and the pure hydrogen is prepared and circulated for the desulphurisation unit. Okay, this product of hydrogen is almost 99% purity. Okay, now we have taken care of entire refinery operations. Now the product concerns in hydrogen. Okay. See, I told you hydrogen. Hydrogen is used for removal sulfur from refinery product. It does not have any value to the product price. Suppose the petrol price is extra rupees, and just because we are using hydrogen for sulfur removal, we are not going to get X plus some Y amount. The price is same. Base price, refinery price is same. Okay. And there is no industrial solution presently for storing hydrogen. A lot of hydrogen is required for these operations, and we don't have any industrial solution for storing hydrogen. So whatever produced hydrogen has to be consumed for hydrotreating. Else, hydrogen will be wasted to flat. So hydrogen consumption has to be kept optimized to minimize operation cost. As a thumb rule, it is only guidelines for understanding purposes. Thumb rule is hydrogen cost is 4 times of naphtha price. Suppose naphtha price is 4,000 rupees, hydrogen cost is 8,000 rupees. This is the thumb rule. So this is the importance where hydrogen conservation is very, very important. And now the industry is thinking of how to store hydrogen using cryogenic methods of storing for industrial use also. which is yet to take place. Now we are using small vessels for vehicles, automobiles. Okay. Now the last part of operations, flare. Many of you would have seen this flare burning gases left and right 24/7, and you might be wondering why it is taking place. Okay, flare in a refinery system is for the safe disposal of toxic gases. So I told you that we are adding H2S and sulfur dioxide, SO2, CO2. Certain we can extract the product up to certain level only, and other products we cannot export. We have to safely dispose, right? Toxic gases produced in a refinery process. So they are burnt in a flare system at different heights, depending upon the environmental procedure in that locations. So we'll quickly go through this again. Okay, no, sorry. We have, you can see that the entire refinery process requires a lot of steam and power, because product has to be moved from one point to another, one tower to another tower. So we need pump. Pump means motor. Motor means power. And also we are requiring a lot of steams where for process steam. Okay. We have a cogeneration plant. This is a simple cogeneration plant where we are using fuel oil. We have excess fuel oil that is used feed for heating naphtha. Excess fuel. Excess fuel is used for cogeneration purposes, and we are using steam to drive the turbine to produce power. And one portion of steam is used for process also. We have different types of steam: LP steam, MP steam, HP steam, that is low pressure, high pressure, medium pressure. Depending upon the process requirement, we are using different types of steams. And we have, apart from this, we have a gas turbine also, because what happens, at one point of time in a refinery complex, the steam demand is already saturated. Okay, but we need more power. So in that case, we go for gas turbine. We produce where focus will be mostly on power, and only that small portion of heat recovery, steam production is taking place. So these are about refinery process. We'll quickly, in a short time, quickly go through the equipment used in the refinery. And these are all huge tanks, used for storing non-volatile product, which is not vaporized, like heavy rains, right? And we have floating roof tanks where the volatile products easily evaporate, like petrol and diesel, which can be easily evaporated in stored in atmospheric pressure. We are using floating roof tank where the liquid is floating along, the roof is floating along with the liquid. When the liquid is full, then the roof will be at top. When the liquid is low, then the roof will be at bottom. That means it ensures that there is no gap between the liquid and the roof, so that there is no vapor loss available. And similarly, gases are stored in mounted bullet, that is pressurized liquid are stored in a mounted bullet, LPG, like LPG and other petrochemical products. And kilometers of pipelines ranging from half an inch to 40-inch diameters are used in a typical refinery for transporting oil from unit to another unit. So just for our information, for a typical 3.5 million tons of refinery, we require around 450 kilometers of pipeline. There is a volume of pipelines required for a refinery. So you can see the complexity of pipeline, and these pipelines are joined either by welding or flange joint with different like elbows and other thing. And we have different pumps, centrifugal pumps and rotary pumps. For slurry fluid, we cannot use centrifugal pump, we use rotary pump, rotary or positive displacement pump. And we have compressors because, as you know, hydrogen compressor is there, and we need to For lube oil system, we need to have ammonia compressor for making it liquid. So compressor required. There will be, I told you, there's a sulfur. The surplus heat of exchanger. No, we have a different type of exchanger, shell and tube, and exchanger, different type of exchanger or different material. You can see here SS heat engine is available. This is ensured the plant is operated without wasting energy. And instrumentation side, we started the refinery operation with pneumatic, where the entire operation is taking place by instrumentor and pneumatic pressure system. Now that has been converted into DCS, high-tech DCS system, where the entire plant like process graphical system DCS is available, which can be used for controlling the entire plant. Now I am done with my presentation. Let me stop this screen share, and if any doubts, we can share it.